Welcome to nanoGPT by Andrej Karpathy. This is a teaching-first implementation of GPT that trades production features for clarity. Think of it as the blueprint you'd want if you're learning how language models actually work under the hood. So what does nanoGPT actually do? It lets you train GPT models from scratch or fine-tune existing ones, and it does this with radical simplicity. You can reproduce OpenAI's GPT-2 architecture or adapt a pre-trained model to Shakespeare in minutes. The secret sauce is transparency. The complete transformer lives in one file you can read in a single sitting, with zero magic and zero hidden layers. The tech stack is refreshingly minimal. PyTorch handles the heavy lifting, TikToken tokenizes text at speed, and Hugging Face provides both datasets and pre-trained weights. There's optional weights and biases logging if you want it, but the core experience needs nothing beyond PyTorch and a GPU. Let's walk through the architecture. First, you run a prepare script that downloads raw text and tokenizes it into binary files. Those token files get memory mapped into the training loop, which feeds batches into the GPT model. The model trains, checkpoints save whenever validation improves, and finally sample.py loads your checkpoint to generate new text. It's a clean pipeline with no surprises. Here's how the code is organized. Model.py is the star of the show. That's your entire transformer. Train.py orchestrates the training loop. Data preparation scripts live under the data folder, organized by corpus. And config files let you reproduce specific experiments like full GPT-2 training or Shakespeare fine-tuning. Everything you need is visible at the top level. Let's trace a training run. You start by calling prepare.py, which writes tokenized binary files. Then you launch train.py with a config. The training script loads batches, runs them through the model to compute loss, backpropagates gradients, steps the optimizer, and periodically saves checkpoints when validation improves. This loop repeats for thousands of iterations until your model converges. Inside the model, token IDs get converted into embeddings by adding learned token and position vectors. Those embeddings flow through a stack of transformer blocks. Each one applies causal self-attention, followed by a feed-forward network. After the final layer normalization, a projection head maps back to vocabulary logits. It's the same architecture as GPT-2, just written so you can see every step. There are 3 typical journeys with nanoGPT. If you're learning, you can train a tiny model on Shakespeare in minutes and watch it generate plausible dialogue. If you're reproducing research, you can train full GPT-2 from scratch on billions of tokens. And if you're adapting a model to a specific domain, you can fine-tune a pre-trained checkpoint in minutes instead of days. Same codebase, different scales. 2 clever techniques make nanoGPT practical. Memory-mapped files mean the training script never loads all 17 gigabytes of tokens into RAM at once. It's like fetching library books on demand instead of carrying them all. And gradient accumulation lets you simulate huge batches by processing smaller chunks and accumulating their gradients before updating weights. You get the training quality of a large batch even on a laptop GPU. Now let's talk about community health. This is a solo project by Andrej Karpathy, and it's currently dormant. The last commit was about 8 months ago. That's not a red flag here. The README mentions this is a teaching implementation and points to a newer project for active development. Think of nanoGPT as a finished textbook rather than an evolving framework. It's stable, complete, and widely referenced, even if it's not getting daily commits. So here's the takeaway. nanoGPT is all about clarity over features. It won't have the latest optimizer or the fanciest logging dashboard, and that's intentional. What it gives you is a readable, hackable implementation of GPT training that you can understand, modify, and learn from. If you want to see how transformers really work or test a new idea without fighting a framework, this is your starting point.